morning to all. Welcome you all from Gaikwad Patil College of Engineering, Nagpur. I, Dr. Praveen Tajne, from Electronics and Communication Department. Today, we will discuss about the timer of PLC. Previous class, we have studied about what is the PLC, what are the components which are available in the PLC, and what are the applications and where exactly use the PLC in industrial automation, process industry, manufacturing industry, like that. So today we will discuss about the timers, where are used in the automation field. There are three types of timers. First is a on delay timer, second is a off delay timer, third is a retentive on timer. First of all, we will study about the on delay timer. What is the timer? Timer where it is used to provide the delay to activate the several number of components and several number of devices. If you want to start the motor after 5 seconds, that time we use the timer. If you want to activate so many devices within some delay, that time also we use the timers. In industry, use the three type of timers: on delay timer, off delay timer, retentive on timer. In on delay timer, what happen? If you want delay to activate some devices after few seconds, at that time we use the on delay timer. But in case of we want the switch on the multiple devices at a time and switch off the some devices after few seconds, some devices on the few seconds, that time we use the off delay timer. In retentive on timer, we use the actually when the power is failure, that time when our particular device is off, so after that same time our device will be continuously switch on. In that case, there is use the retentive on timer. So first of all, we will study about the on delay timer. There are some components which are used in the on delay timer. In this on delay timer, there are some parameters like T4:0. This is the file number. T4, that is the where in PLC use the file number T4, and 0, that is the number where we use from the, suppose there are use the 16 bit, that time it will start from the 0 to 255. So that means suppose if you want the single timer, that time we use the T4:0. If we want to use the second timer, there you use the T4:1. In this way we can use the so many timers. Second is the time base, where it is used to provide the delay. If you provide delay in the second, that time here we use the 1 is the time base, because preset is used to set the value where you provide the delay to activate the several devices. So that time here we use the some set value. Suppose if we use the 2, means delay will be the 2 seconds, means here we will get the 2 multiplied by 1, means here we can provide the delay of the 2 seconds. Suppose here if we use the 4, that time delay will be the 4 seconds, means here will be the accumulator value. Accumulator value is equal to time base multiplied by preset. Then here will be the accumulator value. Means this will be counted by the internally in your PLC, but the time base value, that is defined by our side, and preset value, that depends upon the how much you would like to give the detention. Means here we can provide the delay. The delay will be, suppose if you want a 10 second, that time we can use the 10, means here will be the 1 is the time base and preset is a 10, means 1 multiplied by 10 is equal to 10 seconds. Delay will be the 10 seconds, right? So if you want the 15 second delay, that time here we use the 15, means delay will be 1 multiplied by 15. Delay will be 15 seconds. Suppose if you want to reduce the delay in less than the second, so that time here we can use the time base like 0.1, means our delay will be less than 1 second, because if you multiply it, suppose if you give the preset is a 1 multiplied by 0.1, here delay will be your the 0.1 second, means delay will be very less. In this way you can reduce the delay as per the requirement of the activation of the different devices. If you want to again reduce the delay, increase the delay, at that time we can use the time base. It may be the, if you want to give the small delay, at that time we can use 0.1 or 0.01, so then delay will be the means very less time. In this way we can use the time base, where it is used to provide the delay as per the requirement of the industries. Now here this is the timing diagram where it is used to provide some the flow of the various bits. There are 3 bits which are used in the on delay timer. First is a enable bit, second is a timer timing bit, third is a done bit. Now in this enable bit is used where the rung is on, means this enable bit is on when the rung is on. Rung means actually this portion is called as a rung, means when the supply goes from this higher side to lower side, it is called as a higher potential, and this part is called as a lower potential. Means here we can say that this is a 5 volt and this portion is called as 0 volt. All is a 0 volt. So means the supply goes from higher potential to lower potential. Same thing will happen in this case when rung is on. Rung is on means that supply goes from this higher potential to lower potential. It is called as a rung is on. Rung is on, high means rung is on. Second is a enable bit. Enable bit, when our rung is on, when the rung is on, that time enable bit of this timer will be on. Means suppose if here we are giving the delay as a 10 second, 10 preset value is a 10, 1 multiplied by 10, means there will be the 10 second delay. The delay will be here the 10 second. When the rung is on, that time this bit will be continuously on. Now when the rung is off, that time this enable bit will be off. Means actually it should be on up to this position. Actually when the rung is on, on means supply goes from here to there. So this rung is on up to this position. Then we can say that when the rung is on, then enable bit is on. After that there is a timer timing bit, TT bit is used. When the rung is on, enable bit is on, whatever we provide the delay like 10 second, 15 second, then the timer timing bit will be continuously on for that delay where already we have provided. Means this TT bit will be on for the 10 second. Means here we can write as a 10 second. Then after the completion of 10 second, timer timing bit is on for the 10 second. When the 10 second is over, because here we have provided the delay as a 10 second. After the 10 second, what will happen? This done bit will be active. It is the third bit of the on delay timer. This bit will be active, and after the 10 second, after 10 or equal to 10, then this done bit will be on and rung is, but this happens up to the when the rung is on. So that means what will happen? This should be the on. Means when the rung is on, the enabled should be on, and till that your this done bit should be the on. Means here in this case here we can use the high position. Here enable bit should be the high. Then here easily you can observe that when the enable bit is on, means your timer is on till your this all timer TT bit and done bit will be active. When again rung is off, same time enable bit is off and also the this done bit will be the off. If you want to again switch on the TT bit or done bit, that time again we have to start the rung of the ladder logic programming. That time again you have to start the rung by pressing some various contact, like here or use the start button, stop button, like this. Now in this case you can observe that when the rung is on, the same time your enable bit is on, right? For the same time whatever the we have provided the delay, for that time our TT will be active. Means here this bit TT bit is active for the 9 seconds. Here we can write as 9, just 9 seconds. After the just completion of the 9 seconds, next bit will be on, that is called as a done bit. Done bit is on till the your rung is off. When the rung is off, the enable bit will be off. The same time done bit will be here the off position. If you want to again continue the process, that time again we have to switch on the rung. Same time this enable bit will be on. Again here TT bit will be on for the 9 seconds, and after the completion of 9 means 10 equal to 10 or greater than the 9, that time again this bit it is called as a done bit. Means after the 9 seconds the done bit will be active. Means this process will be continue for the 10 seconds. For the 9 seconds this timer timing bit will be on. After the 9 seconds here the done bit will be active. In this way you can switch on the various devices as per the requirement of the industries, and there are so many devices are used in industries like motors, control wall, pressure wall, electric drives. These are the various devices are used in the industry, and that devices are used to control the various parameters like temperature, pressure, flow, level, like that. Now again I am again revising in terms of the ladder logic programming. Same thing we are implementing in terms of the ladder logic, because every industry, most of the industry use the ladder logic programming, because this language is very easy and easily we can implement to control the various devices as per the needs. This simple switch, it is called as a start button. Start button means if you want to switch on the all things, that time we start this button. This it is called as a start button. When we press this button, that time it is called as a toggle switch. Stop button is there. This is the timer, on delay timer, and these are the bits, enable bit, done bits. When we start this button, that time this supply is given to the timer. The same time what happen, when the enable bit is on, means supply goes from this higher potential to lower potential. That means your rung is on. Rung is on means supply from start from here to there. Means higher potential to ground potential. After this switch on this timer, what will happen? This enable bit is on. From this timing diagram you can observe that when the rung is on means when the switch on this button, that time supply start from here to there, means we can say that rung is on. Rung is on means we can see that from the timing diagram, rung is on means same time this enable bit will be on, mean this is the enable bit, this enable bit is on till the rung is on, means here you will get the green LED in switch on position. Second time, as per the providing delay, instead of the preset, suppose here we provide the 5. 5 is the delay, 5 means 1 multiplied by 5, mean delay will be the 5 seconds, right? After 4 seconds, the done bit will be active. As per the, we have discussed the timing diagram of these various bits. Here you can see that after the 4 seconds, this done bit will be active. But up to 4 seconds, means we can say that 1, 2, 3, 4. Up to 4 seconds, what will happen? Here you can see that up to 4 seconds, you can see this timer timing bit. We have set here the 10 second delay timing. Up to 9 seconds, the TT bit will be active. Okay, here TT bit is active for the how many seconds? For the 4 seconds. TT bit active for the 4 seconds. You can see that for the 4 seconds, this red LED will be on only for the 4 seconds. After the completion of the 4 seconds, here this done bit will be active. Condition is that or value, preset value should be the this is the set value, no? So if you want to start this blue light after the 4 seconds, this done bit will be active, means here T4:0 / done bit will be active after the 4 seconds. After 4 seconds, if after the completion of 4 seconds, this LED will be on, blue light LED will be on. But up to 4 seconds, this red light LED will be on. After completion of the 4 seconds, here you can see that this blue light LED will be on. But what happened? What happened for the done bit? If you want to start again, start the same process, so here you can use here as a reset of the timer. Means actually this done bit will be activate for the particular period, that depends upon the setting in the particular sections of the industry. Then if you want to again continue this process, that time here we can use timer, reset timer. After resetting this timer, again the process will be continued. Here you can use the, again suppose instead of this you can, if you want to delay, that time again you can use another timer. If you want to use the directly reset after the completion of this process, here you can use the T4:0 / done bit. Here directly you can reset this timer T4:0, means when this bit is on, the same time reset, this instruction will be activate and same time a process will be repeat again. So in this way you will get the repetition of the process. If you want delay for this position, again you can use another timer. There are so many outputs are used, that time we can use the so many timers. Here I am giving the example of the only one timer, but industry there are used so many timers, because with the help of that so many timers we can control the multiple devices which are used in the industries, because every plant having the so many sensors, actuators, flow levels, flow sensor levels. These are the devices where are used to measure the various physical parameters. Now this is about the arm delay timer. Lastly, I would like to summarize that arm delay timer where it is used to provide the delay as per the requirement of the industry. Suppose if you want to provide the delay 10 seconds, our TT will be active for the 10 second, 9 second. After just completion of the 9 second, another bit will be active. That is called as a done bit. If you want repeat this process, that time again we can use the another timer, or directly you can use the reset. RES, that is the instruction where it is used to reset the timer. Which timer you would like to reset, that time you have to put the address over here, T4:0. Means I have to reset this timer, I have to continue this process. At that time we can here use the this timer number T4:0. Suppose here I am using the another timer. Suppose here I use the T4:1. I want to continue this process. That time here we can use the T4:1. Means whatever we want things, that time we can use the particular address for the particular timer. In this way we can control the so many devices where are used in the industry. Thank you for this on delay timer.